Okay, when you have a polygon, a regular polygon, so that means the sides are all the same, you can always break a regular polygon up into equal triangles to the amount of sides. So because this one has 3 sides, we can create 3 equal triangles. So if I put it in the center and I break it out like this, okay, those blue triangles are all equal. So, I mean, similar. So then if we look around here, if I did that, that would be 360 degrees. So this little angle in here is going to be 360 divided by 3, which is going to be 120. So if I'm looking at this blue triangle now, I can see what I know is that it's got 16 centimeters, and I know that this is 120. Now these are also equal down here, so they must each be, because it 30 each, because we've got to add up to 180. So I know that much. Now if you look, we need to get the diameter, so it'd probably be handy if I knew the radius of the circle. So if I go to find the radius first, now if you have a look, if I cut straight down there, that's the radius of the circle there. So it's like I'm cutting down here, and then you can see I create a new triangle. I can create a new right angle triangle if you like. And so if I create that new right angle triangle, so we've said that this is the radius, we know this is 30. Now we're also cutting this bottom one in half, so I can see that must be 8. So I've got, that's 8, and you can also work out that this 160 because it's half of the 120. So we've got enough information there to find the radius using SOHCAHTOA. So I might use, I'm going to use the radius, and I'm going to use 60 degrees, and I'm going to use 8. So if you look at it, I've got opposite over adjacent. So I'm going to write tan 60 equals 8 over r. If I rearrange that, that'd be r equals 8 divided by tan 60, or you can do solve or whatever. And you end up with your radius being 4.62 if I just do that, and therefore diameter is equal to 2 times r, which would be 2 times 4.6 or whatever. So if we get that, so we get 9.2 centimeters is the biggest diameter.